This video is going to focus on graphing exponential functions. First, we're going to talk about what the difference is between a function and an exponential function. Then we'll take a look at some exponential functions and look at how we can decide just from the function how to tell how it is shifting, whether it's going left or right or up and down. And we're not actually going to graph any of these functions. If you want to graph them, the best choice you're going to have is to use a calculator that has a graphing feature, such as a TI-84 Plus or whatever you use to graph in your class in general. Those calculators will be able to graph much better than I can do by hand with these, so we're just going to talk about the basics, what are they, and how do we determine the shifts. So with that said, let's take a look at some. Take a look at these two functions and see if you notice the difference. Both are using the same items. They have a 3, an x, and a 2, a 3, an x, a 2, and they both have addition somewhere. But the main difference is over here, our variable x is in the exponent area. It is an exponent, which means this 3 is not a coefficient like it is over here. It is a base, and we're raising it to the x plus 2 power. Well, how does that change things? Let's say for a second that x equals 2. Okay. In our general function, our regular one, if I put in x equals 2, we're going to have 3 times 2 plus 2. 3 times 2 is 6, plus 2 gives me 8, so our answer is 8. But in an exponential function, if I put the 2 in for x, I'm going to have 3 being raised to the 2 plus 2 power, which means it's actually 3 to the 4th power, which is 81. Much bigger. So exponential functions can either get really big or really small really fast. And it's all based upon our exponents up here. And you can have x plus something, x minus something. It doesn't matter. It'll change how the graph works. So, with that said, the title of this video was Graphing Exponential Functions, and there are two main types of exponential functions that we are going to be discussing. We've got growth functions and decay functions. So our first step is to decide, is something a growth or a decay function? And what is the way to tell it apart is very simple. So let's get an example of both. Here we have two exponential functions. They look similar, but their bases are different. One has a base of 2 being raised to the x power, and one has a base of 1/2 being raised to the x power. And these two simple exponential functions are the best way to show you what the difference between a growth and a decay function is. In a growth function, your base is going to be bigger than 1, and that's important, so I'm going to write that down. Growth base greater than 1. It can't be exactly 1, it has to be bigger than 1. So it could be 1.1, it could be 1.00001. As long as it is bigger than 1, it is going to model a growth function, meaning it's going to get bigger over time. Now the opposite of that is a decay function. And you can tell by here, our base has to be less than 1, so I'll write that down as well. Base is less than 1. If it is less than 1, the function is going to get smaller and smaller and smaller over time. So that means it could be 0.9 because that's smaller than 1. It could be 0.99999 continuing. As long as it is smaller than 1, it is going to model a decay function and get smaller and smaller over time. And those are the two main things you have to look at for deciding if it's in growth or decay. Look at your base for the exponent and decide, is it bigger than 1 or is it smaller than 1? There you go. Now, let's put this to use. Here we have the exponential function 3 raised to the x minus 2 power plus 4. And Deciding the shifts for an exponential function is very similar to deciding the shifts for a radical function. First, the exponent determines horizontal, so let's write that down. Exponent equals horizontal shift. And since we have an exponent with -2, that means we are going to do the opposite. So if it's -2, the shift is +2. So another way to think of that is we need to do exactly the opposite of what it says. If this says that we are going to go -2 or to the left 2 on our graph, because remember, negative is left, then we have to go to the right. So I'll write this down here. Hopefully it makes sense to you. If x minus something, shift right the same amount of units. If x plus something, we shift left that amount of units. So let's say it was x minus 5. Well, we're going to shift to the right 5 units. And if it was x plus, let's go with 6, then we would shift to the left 6 units. So we basically do the opposite of whatever is up there for our shifting. Alright, so that's a horizontal shift. Vertical shift is much easier. Remember, vertical is up and down. And that is based solely off of what is being added or subtracted to the base with the exponent. So we'll say that's our constant. If we have plus constant, shift up. If we have a minus constant, shift down. So that one follows how you would think. If it's plus, you're going up. If it's subtraction, you're going down. So these are the vertical shifts. I should have written that next to it, so hold on. Let me get that in there. Vertical shifts. And if we're going to use our example here to determine the shifts, well, first thing I would say is, well, this is a growth function because our base is bigger than 1. So this is a growth function. Pardon my poor writing. And then if I look at the exponent part, it has a -2. So that means I have to do the opposite. I have to do +2. And if it's minus, we're going to shift to the right. So it would be right 2. And then, since after the base and exponent we have a +4, that's plus a constant. So I'm going to shift up 4 units. So we go to the right 2, and then we go up 4. And that's how we can tell, just by looking at this, not even having to graph it, whether it's growth or decay, all based on the base. It shifts to the right 2 because this is a -2 up here. And then it goes up 4 because we have a +4. Let's try 2 more examples, and then hopefully we'll be on the right track towards getting a good grasp of exponential functions and how to graph them. For our second example, here we have the function of x equals 1/3 raised to the x minus 1 power plus 2. And just like before, we want to tell, is this a growth or decay function? And then how is the function shifted? Well, if we want growth or decay, we got to look at our base. And notice the base is a fraction. This means that it is smaller than 1. And what did we say about bases that are smaller than 1 in exponential functions? That's right, it means it is a decay function. So we can say that this is decay. And now we can tell which way is it shifting, left or right, up or down. So to determine the horizontal shift, look at the exponent. We got x minus 1, and since it's minus 1, we're going to be going plus 1, which means we have to shift to the right. So we shift right just 1 unit. And then to determine whether we're going up or down, we look at the constant. And just like the last example, it is a plus 2. Since we are adding, we are shifting up. So we have a shift up 2. And there we have it. 3 simple steps. Look at the base. Is it bigger than 1 or smaller than 1? Since it's smaller than 1, it's a decay. Look at the exponent. Take the number and do the opposite, so we're shifting right 1. And then take a look at the constant and the sign. It's addition 2, so we are going up 2. Alright, let's try one more example that is about as ugly as we can make it for the time being, and see how we do. Alright, for our last example about shifting, here we have the function of x equals 2 times 3 to the x plus 2 minus 1. What's ugly about this example is the fact that, well, you've got a 2 and then you're multiplying it by the 3. And you might be thinking, oh, I can simplify this. This is going to become the function of x equals 6 to the x plus 2 minus 1. This is absolutely wrong. Order of operations has to take place. And before we do any type of multiplication, we have to take care of our exponents. So while it may look weird to have it written like this is actually the proper notation. We have to do this first before we can multiply anything. So, now that we know that, is this a growth or a decay function? Look at our base. Even though there's the 2 here, we can ignore it when we're deciding if it's growth or decay. And since the base is a big number bigger than 1, this is a growth function. Now, we need to know the horizontal shifts, so we look at the exponent. This is x plus 2, so I have to take the opposite. It's negative 2, and how do you get to negative 2 on your graph? You go to the left. So we shift left 2 units. We have to do the opposite. Plus means right, so we have to go left. And then our constant over here is subtracting 1, minus 1. That means for the vertical shift, we're going down 1. So we have to follow it as it says. So shift down 1. And there we have it. Deciding if it's growth, and then determining how we shift. Now there's one more topic we haven't quite discussed yet, and you'll be able to see this better if you actually graph your functions, but that's about domain and range. Domain and range, remember, is the fact, well, it's not a fact, but it's how the function behaves on the y-axis and how it behaves along the x-axis. So for domain, this is the x-axis. For the domain, any of our exponential functions are pretty much going to have the same domain, which is all real numbers. Because whether it's negative infinity or positive infinity, the function will eventually reach it. The range is your y values, and this is determined by 2 things. Generally, it's all positive y values, but if you shift, like we had to do here, that'll change. So like for this one, the graph is never going to get smaller than negative 1 on the y-axis. It will get bigger though. So our range would be y is greater than or equal to negative 1. Because, let's say, I'll try to do a quick little graph. We have our axes right here. this negative 1, we'll say, is right about here. And the way the graph will work is it's just going to be coasting along at negative 1 until we get to a certain point, and then it's going to start going up, 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 up real fast. So that shift down tells us that y is never going to be lower than negative 1, which means we have to say y is greater than or equal to negative 1. Let's do one more domain and range example, and then that is it for the video. So for our final example here, we have the function of x equals negative 3 times 1/2 raised to the x minus 1 plus 2. And I've done my best effort of graphing it over here. It's pretty crummy, but it'll work for what we need to do. And I've identified our parts about it already. It is a decay function because our base is 1/2. It's shifted to the right 1, and it's shifted up 2. Right 1 because we had a minus 1 here, up 2 because of this. Now this will look different because we have a negative in front of it. That flips the graph upside down. So while generally the graphs will look something like this, as you can see here, it's kind of flipped because of that negative. Now, how does that affect our domain and range? Our domain isn't affected at all by the flip. If I were to continue this graph going this way, it would still hit all of the negative x values, and the graph is going to continue going this way as well, hitting all the positive x values. So the domain is still just all real numbers, which I'll abbreviate ARN. What changes with this one, though, is look how the graph is starting to level off here. If we were to continue the graph going towards the right, this would basically become a straight line as it's approaching the value of 2. It never quite gets to 2, but it's reaching the value of 2. And that's the highest it's going to get. It's never going to get to 3 or 4. It's going to stop at 2. So we say that for our range, it's everything below 2. So our range would be y is less than 2. Because it's going to keep getting closer and closer and closer. It's going to look like it's exactly small, and or really, really small and close to it. Your calculator may even round up to eventually saying 2, and that tells us that, yes, it's going to get to 2, but it's never going to get bigger. So there's our domain and our range for a couple functions. I hope you have found this video helpful, and good luck.